The invention of semiconductor electronic devices have made a drastic change in the field of electronics engineering. Earlier we were using tube devices like triode, diode, etc. Now it has been replaced by semiconductor devices. The semiconductor devices, when we are comparing with the tube devices, has very less size and the power consumption also is very less. Even the computer that we are using today is having so many integrated circuits which are made by using semiconductors. So, today I would like to talk to you on the semiconducting materials, what are its properties and what are its applications like that. And the topic that I am going to discuss with you is to learn about the semiconducting materials. Only the basic part will be discussed here, and to understand the structure of the semiconductor material and to know about the applications. As you all know, you might be knowing that the materials in general can be classified into three types, that is conductors, which are used for carrying electricity, and semiconductors and insulators. The materials are classified according to their energy band. I will show you the energy band diagram. On the upper side of the diagram, it is the energy band diagram of the conductors. Here, two bands have been shown here. One is valence band and the other one is conduction band. Valence band is the energy level of the electrons which are bound to the nucleus of the atoms. So, they are not free electrons, they cannot move in between, and the conduction electrons or the conduction band gives the energy level of the conduction electrons which are free to move. The electricity through a conductor is carried by the conduction electrons or the free electrons. Here you can notice that the valence band and the conduction band energy level coincide each other. That is, there is no gap between the valence band and the conduction band. Actually, in the room temperature itself, most of the valence electrons in the outermost shell of the atom becomes free electrons. That is why the conductors like copper, silver, aluminum, etc. are able to carry electricity. In the middle part is the energy band diagram of the semiconductors. Here you can notice a slight energy gap between the valence band and the conduction band. The energy band is, or the energy gap is indicated by using the unit called electron volt, which is a very large unit as far as energy is concerned. So, you can notice here that 1.1 electron volt is the energy gap between the valence band and the conduction band in the semiconductor. So, if we are giving a small input of energy to the valence electrons, they becomes free and its conductivity increases. That means, we can control the conductivity of the semiconductor devices. In the normal or room temperature, it may behave as an insulator. So, if we are giving a small amount of energy like heat or electricity or light, it its conductivity increases. And in the bottom figure is the energy band diagram of the insulators. Here you can notice that there is a wide gap between the valence band and the conduction band. So, it is shown as 8 electron volt. It is a very large unit. So, in insulators we cannot impart energy to the valence electrons to become free, because if we are applying 8 electron volt, valence electrons may become conduction electrons, but when we are applying so much of energy, its crystal structure will collapse. That is why in insulators we cannot increase its conductivity. So, these are the types of 3 materials or the classification of 3 materials. So, here we are discussing about, or we are going to discuss about the valence semiconductors, which has very less energy gap between the valence band and the conduction band. And the types of semiconductors. The semiconductors are classified into 2, that is intrinsic semiconductors and extrinsic semiconductors. The intrinsic semiconductors are semiconductors in its pure form, that is pure semiconductors are called intrinsic semiconductors. The examples of semiconducting materials are silicon, germanium, like that. And silicon or germanium in pure form is called intrinsic semiconductors. Extrinsic semiconductors are impure semiconductors. We are adding some sort of impurities into the pure semiconductor, then it becomes extrinsic semiconductor. Addition of impurities in the pure semiconductor is called, or the process is called doping. When we add impurities into the pure semiconductor, it becomes extrinsic semiconductors. Why we are adding impurities into the pure semiconductor is to increase its conductivity. Most of the semiconductor devices are manufactured by using extrinsic semiconductor or impure semiconductors. The application of pure semiconductors are very limited. So, we will be concentrating more on the extrinsic semiconductor. As I told you earlier, the process of adding impurities into the pure semiconductor is called doping, and doped semiconductors are called extrinsic semiconductors. And extrinsic semiconductor, depending upon the type of impurities added, can be classified into 2, that is N type semiconductor and P type semiconductor. Here we will take silicon as the example of the pure semiconductor. You may be knowing that silicon has 4 electrons in its outermost shell. When we are adding a pentavalent impurity means it will have 5 electrons in the outermost orbit. The impurity selected for doping should have the same size for the nucleus as when we are comparing with the silicon or germanium. So, arsenic antimony, we are adding arsenic or antimony which has 5 electrons, which has got 5 electrons in its outermost orbit as impurities. So, when we are adding pentavalent impurity into the silicon or germanium crystal, the silicon or germanium crystal is having 4 electrons in the outermost orbit. When we are adding a pentavalent impurity, it dislodges one of the silicon atom and takes the place of it. So, it will share all the 4 outermost electrons with the neighboring silicon atom. So, one electron will become excess, that is called excess electron. That will be treated as a free electron. When we are adding each pentavalent impurity into the silicon or pure semiconductor, it donates 1 electron into the conduction band, because it has binding only with the nucleus of the impurity. All other electrons will be shared with the or it will be within the covalent bonds of the silicon atom. So, n-type materials are constructed by adding pentavalent impurity into the pure semiconducting material. If we are adding trivalent impurity such as boron, aluminum etc. into the pure semiconductor, it will become a p-type semiconductor, because it has got only 3 electrons in the impurity has got only 3 electrons in the outermost orbit, and it will share with the covalent bonds of the silicon crystal, and one deficiency of electrons will be there to complete the covalent bond, and that deficiency of electron is known as hole. It has a positive charge, whereas excess electrons is having a negative charge. So, that a deficiency of electrons will have a tendency to attract electrons from the neighboring atoms or somewhere. So, that is why it is having a positive charge. So, that deficiency of electrons will also help in the conductivity. So, the extrinsic semiconductors are classified into n-type and p-type depending upon the type of impurity added into the pure semiconducting material. We were discussing only about the semiconducting elements like silicon, germanium, and there are some semiconductor compounds also used for manufacturing electronic devices. They are gallium arsenide and gallium arsenide phosphide, and gallium arsenide is used for making microwave diodes, and gallium arsenide phosphide is used in manufacturing LEDs, light emitting diodes. Now, the applications of semiconducting materials, I am mentioning only 2 or 3 applications used for making diodes, transistors and integrated circuits, ICs. I will show you some of the diagram of diodes. A semiconducting diode will look like this, and the figure shown below is the symbol of the diode, and this is the light emitting diode, which are also manufactured with gallium arsenide phosphide. I think that I have given a basic introduction of the semiconducting materials. Thank you.